Hello everyone and welcome. Today we are going to explore a powerful solution for one of the biggest challenges in asset management, truly understanding your clients. The goal is to build what we call a client wealth map, a complete 360-degree view of every aspect of your client's financial life. By mapping their asset ownership and financial goals, we can move beyond generic service and start creating the hyper-personalized experiences that build lasting relationships. In this demo, we will show you how to build the foundation of this map by leveraging the power of Snowflake and the Relational AI Graph Co-processor. Before we get to the code, it is important to understand what Relational AI is. It is not another database. It is an AI co-processor for your data cloud. It allows you to build knowledge graphs directly on top of your existing Snowflake data without moving or copying anything. This is all possible because it's available as a Snowflake native app, which means the code and the processing run securely within your account. First, let's look at the structured data we are starting with. For this demo, it is just a single table in Snowflake called asset ownership. It contains client ID, asset type like equity or mutual funds, and the specific asset tickers owned by those clients. We have data for several clients showing their diverse portfolios. Now for the exciting part where we write our first lines of relational AI code. It is remarkably intuitive. The very first thing we do is create a model. You can think of a model as the main container or workspace for your entire project. It is going to hold all of your data sources, our definitions and the rules that connect everything together. This first line, we need to define the categories of things that will exist in our graph, the nouns of our data. For this, we use a model.type. A type is what we use to define the nodes in our graph like clients, assets, or transactions. In the second line, we are creating our first type called the asset ownership. Notice the source parameter, we are pointing it directly to our asset ownership table in Snowflake. This tells our model that every single row in that Snowflake table is an instance of the asset ownership type. And just like that, with only 2 lines of code, we have established a live link to our data. There is no complex ETL or data pipelines to build. Relational AI will read the data right where it lives, treating our Snowflake table as a native part of its knowledge graph. Later, we will create other types like client and asset type to build out the rest of our graph structure. We will define the components of our graph now. We are creating 3 types of nodes. A client node that will represent each unique client. The asset type node for categories like equity, ETF, and mutual fund for all the various asset types that are out there. And then client specific asset to represent the actual assets like and mutual funds and ETFs owned by the specific client. Then using a series of simple rules, we instruct RAI how these nodes are connected. We will create edges from a client to the asset type they own, and from that asset type to the specific asset owned by that client. With our model defined, we just call the visualize command to visualize our entire graph. And there you have it. With just a handful of declarative rules, Relational AI has automatically read our Snowflake table and constructed a complete knowledge graph for our clients' portfolios. We can see the clients connected to the type of assets they hold in the middle, which then branch out to the specific assets. This is the client wealth map coming to life. But a graph isn't just a pretty picture. Its real power lies in analysis. Let's say we want to find clients with similar investment strategies. We can use a graph analytics technique called checkout similarity. This measures the similarity between 2 sets, in our case, the sets of assets owned by 2 different clients. We write a query asking who has a portfolio similar to client G. Look at that. In seconds, RAI has calculated the similarity score for every other client compared to client G. We can see that client J has a very high similarity score. This is a powerful insight. It suggests that a product or strategy that appeals to client G might also be perfect for client J. Let's verify this visually. We can easily filter our graph to show only the portfolio for client G. Here we go. Here you can see client G's holdings, a mix of equities, ETFs, and mutual funds with specific tickers like V, PG, and KO. Now let's do the same for client J, who the data suggests is our most similar investor. As you can see, the structure of their portfolios are strikingly similar. They hold many of the same assets, confirming our Jacquard similarity result. Imagine being able to do this across thousands of clients instantly. You could create automated client segmentation, identify opportunities for new products, and provide truly personalized advice at scale. Here, I have visualized both the graphs for your information, client J and client G. What we have shown you today is just the beginning. By building on this graph, you can unmask influence using centrality measures or perform community detection to automatically segment clients into highly nuanced groups. This allows you to spot emerging trends and develop new products for a well-defined organic client base. By combining the unlimited data capacity and security of the Snowflake data cloud with the power of Relational AI co-processor, building a deep, actionable understanding of your clients has never been more straightforward. Thank you for watching.